In our previous examples, we used the limit laws to evaluate limits by substituting in the value of x, and at times we needed to use some algebra tricks to do some manipulation before we used the limit laws and substituted. And up to this now, we've gotten finite numbers. We've actually gotten a number and an answer. But sometimes that doesn't happen. Sometimes we get something where the denominator is approaching 0, but the numerator is not. So we get this form k, where k is some number over 0. And when that happens, a function can either increase or decrease without bound, and it leads us to a limit that is infinite. So again, I want to stress that that doesn't mean the limit exists. That just describes the behavior of the function when we approach that value of x. So in these problems, we need to determine not only whether the function becomes infinite, but also whether it grows or increases without bound, meaning it would be a positive infinity, or if it decreases without bound and goes to negative infinity. When we look at this limit, the very first thing you always want to do with any limit is try direct substitution first. Now, when we do that, we end up getting -1 over 0. So we get this form, k over 0. We have some number over 0. The next thing you might want to do is see if you can factor or simplify or use some other method to rearrange the function in a way that we can use direct substitution. In this case, I would try factoring because we're dealing with a rational function. If I factor the denominator, I can factor out an x, and that leaves me with an x plus 2. But that doesn't get us anywhere either because there's no factor that cancels that will rearrange this function and make it easier for us to do a substitution. So this tells us that there's nothing we can do, and we know the bottom is going to get smaller and smaller and smaller, which means the whole fraction is going to get bigger and bigger and bigger, and it's going to blow up. Now the question is, which way is it going to go? Is it going to go to minus infinity, or is it going to go to positive infinity? So what you want to do when you have something like this is try to break it up so that you take the part of the fraction out. See if you can factor it out, the factor that's the problem. The problem that we have here is the x minus 2 in the denominator, because if I plug in 2 and try to use direct substitution, that is the factor that causes me to have 0 in the denominator. So I'm going to rewrite this as x minus 3 over x times 1 over x minus 2. I want to separate the part of the problem, if possible, that's giving me the issue, and then look at them individually. If I try plugging in using direct substitution into the first fraction, I shouldn't have a problem because I separated the problem part, okay? So if I plug in 2, I get 2 minus 3, which is a -1. And then on the bottom, when I plug in 2, I just have a half. Now I want to find the limit as x approaches 2 from the left. So if I think about plugging in values in for this x, getting closer and closer to 2, but because I'm approaching 2 from the left, I know the values that I'm plugging in for x are going to be less than 2. Okay, so I'm plugging in numbers like 1.9, 1.99, 1.999, okay? And because the numbers that I'm plugging in for x are going to be smaller than 2, that's going to constantly give me a negative number in that denominator. So for example, if I plug in a number close to 2, 1.9, and I subtract 2, that's going to give me a negative number. If I plug in 1.99, that's going to give me a negative number. So I know that this part coming from the left is going to give me a minus infinity. because the number on the bottom is getting closer and closer to 0. So the whole fraction is getting bigger and bigger. But in which direction is it going without bound? This is telling me because the denominator is negative, it's going in the negative direction. Then if I take that along with this negative, so the two negatives for each of those factors gives me a positive. So that tells me that the limit overall, after we look at the whole thing together, the limit as x approaches 2 from the left of this function, x minus 3 over x squared minus 2x, that's going to approach positive infinity. It's going to grow without bound. Now, let's say we were approaching from the right-hand side. Let's look at it. Even though it's not technically part of the problem, let's look at that. If I take the limit as x approaches 2 from the right, that means I'm going to have a negative 1/2 because I plug in 2, and I have 2 minus 3 over 2. That gives me negative 1/2. But when I look at this piece, the part that's the problem, if I'm coming in from the right, I know that these values that I'm plugging into x are bigger than 2. So 2.01, 2.001. So those values are bigger than 2. So when I subtract 2, I'm going to get a positive number. So that means in the case that I'm coming from the right, this is going to go to positive infinity. And then when I take that factor along with the negative, I have a negative times a positive. So in that case, if the limit was approaching 2 from the right of that function, I would end up with a negative infinity because I have this negative and this is approaching positive infinity. So that would give me a negative infinity.